Thank you. So I'd like to begin with a brief overview of why we are interested in all electric systems in Total. What is the stimulus for us to look at this technology? So in Total R&D, we have an objective to develop new technologies that will enable us to deliver safer, cleaner, and more efficient operations in the future. And for this, we see all electric gives us an opportunity to reduce our environmental impact. Electrification of our offshore facilities is a key element of our CO2 reduction ambition within Total. We see opportunities removing the continuous delivery and use of hydraulic fluid in our subsea systems, and the potential to reduce or completely remove our manned offshore facilities in the field. We see opportunities to reduce our capex with all electric, especially in our deep water developments. The reduced size and weight of the key infrastructure elements like the Christmas trees and the manifolds, the removal of electrohydraulic and chemical umbilicals, and ultimately the potential removal of the topside floating facility altogether. We see opportunities to improve operational efficiency through both the way the technology operates, but also in the reduction of subsea interventions. We see an opportunity to improve automation and remote control. This is an inherent benefit of the all-electric system over the typical hydraulic systems we have today. Also, frontier water depths. The electric technology is less dependent as there's less impact of the hydrostatic pressure on the electrical equipment. So we see the ability to go to water depths beyond 3,000 meters. And also to enable ultra-long step-outs, going much further, and most importantly, to realize the potential of subsea-to-beach architectures. So on that, the all-electric subsea-to-beach architecture, it's a very important part of the vision within Total R&D. And to describe some of the technologies that we're developing, I've got a brief movie that goes through and describes these in a bit more detail for you.
Total opens the way to subsea to shore for the development of oil fields far from the coast without the need for surface installation. Economically viable with a barrel at $50, this disruptive architecture can be implemented down to 3,000 meters of water depth. The key to this progress: an all-electric architecture, lightened and simplified thanks to disruptive subsea technologies, and very robust and reliable. An AUV, a resident autonomous underwater vehicle, provides regular and frequent inspections of pipes and other subsea assets without surface assistance. A central unit distributes the electrical power, transmitted from the coast by an underwater cable, to all production and processing systems. The AUV is fitted with an automatic pipeline monitoring system and a whole array of onboard technologies. Springs, the first subsea unit capable of removing sulfur from seawater before injection, delivers filtered water to 1/100th of a micron. New generation composite jumpers connect the water injection line to the injection wells. In the event of damage, an innovative solution based on epoxy resin wrapping allows temporary repair of underwater lines. Innovative technology ensures the storage and injection of chemicals at the bottom of the sea. Unmanned vessels are occasionally used to safely intervene on these units at the lowest possible cost. An automatic subsea pig launcher is placed at the end of the production line. Operated from the coast or from an unmanned vessel, this pig launcher sends the pig that circulates with production back to the coast for regular cleaning of the pipe. The production line is fed by an all-electric production system with standard equipment. The single production line is heated in the shutdown phases to prevent hydrate formation. It is sized according to requirements based on the advanced simulations performed with LidaFlow, a dynamic multi-phase flow simulation code. A multi-phase pumping system provides the energy needed to boost production to the coast. Over a distance of 150 kilometers and more. Onshore, a surface pig receiver is operated by autonomous robots. This new generation robotics marks the paradigm shift driven by the subsea to shore and the group's inventive capacity at the forefront of economic conquest and responsible deep offshore development.
So we can see from this video that the electrification of a subsea production system involves a lot of new technologies. All these are being progressed today. But one of the key elements of this is the all-electric actuator, the valve actuation. And I mentioned in the title of this talk that this is an industry initiative. And we have a number of JIPs, joint industry projects, involving most of the major operators and all the major SPS suppliers in this, with Technip FMC, Aker Solutions, OneSubsea and Baker Hughes, all involved in JIPs, developing the next generation of the all-electric systems. We also have a lot of work going on looking at how we can improve the efficiency of these systems, the removal of springs, for example, and replacing them with battery fail-safe system designs. And finally, of course, we want to standardize the requirements for these systems. They're not really well covered today in the existing industry standards. So we've worked together with BP, Chevron, ExxonMobil, and Equinor, and have developed a common set of requirements for this technology. And this now is going to be implemented into the next release of the relative industry standards. So thank you for your time. I hope this has triggered some interest in this exciting topic. And we believe in Total for sure this is the future of our offshore subsea production systems. Thank you.